Great. Welcome everybody. I'm really excited to work with everyone on this call going forward in the Science Collaboration Coordinator role. And we're really excited to hear today about some updates from Rubin, and in particular, I think the news is kind of leaked out, but the starting of alerts. So I am putting in the chat, if you didn't already see it, a link to the notes document. So please sign in. And if you're willing to help Melissa and I, put in notes as we go. And then the slides and the recording will be shared after the meeting. So yeah, with that, I think I'll let Phil, Keith, and Eric take it over.
Great, thanks very much. Good to see you all, Science Collaboration Chairs. Um, so we find ourselves at a pretty exciting time, having waited for many years through construction and commissioning. Now at the point where the Rubin system as a whole, both the Summit facility and the data management system, is working well enough that we can be thinking of putting out the first alerts to enable time domain science and so on. So that's what we're here today to tell you about. I wanted to start with, just this picture that you might remember from first look. This was the asteroids flying across the screen, and I remembered this morning when thinking about how to best portray the excitement I feel about the alert stream turning on. I mean, it was so much fun seeing these asteroids flying across the realization, the remembrance that we have here a system that is capable of just turning up so many new things as in the difference images, that it's just going to be enormous fun to work with it. I also wanted to flag to you this link at the bottom. If you haven't found it already, there's plenty of public outreach materials. This backdrop came from a introduction to Rubin slide deck, which is I found very useful for public talks, and just wanted to remind folks of that. Okay, so our program today, I'll say a few words of introduction in a minute. I've got a couple of slides for you, but we'll spend most of the time, I hope, hearing from Keith Bechtel, who, as you may know, is our early operations optimization team lead. He's going to give us an update with some technical detail on the current performance of the Summit facility at Rubin. And then we'll hear from Eric Belm, who is the data management alert production lead. He'll tell us about the status of the alert stream, the readiness of the brokers, give us some outlook on template generation and so on. And then we'll close with a few more comments on the upcoming schedule. And as well as Eric and Keith, we do have here with us Željko as head of LSST, and I trust that he will chime in with expert commentary throughout in that role. Okay, so Rubin is working. There's been steady progress on key aspects of Summit system performance since the transition to operations. We call this period that we're now in early operations optimization. It's before the LSST survey starts, but it's since the operations team took over the Summit facility. They were already operating the data facilities. So Rubin is working. The data management system is performing well. Prompt processing, as you'll hear, has been working routinely throughout this early operations period, and even a bit before then. You'll hear from Eric that the alert brokers are in final end-to-end testing, and they're in coordination with Aon, the follow-up system. So more detail from Keith coming up in a second, but LSST CAM has been at its operating temperature for coming up to a year. Working well, as you've seen then through that time. We do have a scheduled maintenance period coming up in March, and we'll be off Sky for about 3 weeks in that. So you can see how there's some complicated scheduling thinking to do about where to start the survey relative to that. What we're now thinking is the LSST survey will not begin before late March, might be later. And so the way to think about February is as an opportunity to start testing science analyses with the initial alert stream before we start the survey. So the alert stream volume will be low at first, and that will be true in the early part of the survey as well, just the deep drilling fields. Okay, so that's the high-level context for this. Keith, do you want to unmute and walk us through your slides?
Sure. Thanks, Phil. Can people hear me okay? Just checking the audio. Okay, good. I'm going to give an update on the summit performance, and I'm wearing my Rubin hat in this situation, just rather than my desk hat. So if we go to the next slide. Okay, so all the information I'm going to talk about today is I think the same type of information that's conveyed in the weekly early operations updates that are posted on LSST community forum. But what I'll try to do today is give a summary and include some of the plots and more detailed diagnostics just to fill in and provide a bit more context. So I'm going to talk about the survey speed and the delivered image quality. The summary for the survey speed is that as we've been moving from engineering to sustained pre-LSST observations, we're seeing an increase in the overall efficiency. That's fewer faults, fewer interruptions, more time just taking images throughout the night. Part of the gains is that we've been continually working on the software control systems that basically control how quickly we can do the slew and settle. And in particular, the visit gaps are now reduced to a median of about 8 seconds in the pre-LSST observations. We are also making improvements in the overall system availability, such that we're now utilizing nearly the full period between -12-degree twilight from the evening to the morning in the sustained FBS-driven pre-LSST observing mode. For the delivered image quality, we are seeing a median delivered image quality that's a level between 0.9 arc seconds and 1.1 arc seconds PSF full width half max, depending on the band. So we are achieving, I would say, an arc second wide area image quality. We are estimating an instrumental contribution from the optics and from the camera diffusion at the level of around 0.45 arc seconds to 0.5 arc seconds within the past couple weeks. And that's running with a configuration for the feature-based scheduler that is effectively the baseline LSST, but with the addition of inserted active optics system closed loop iterations after each filter change. And I'll talk more about that in the slides that are coming up. We have a elevation and rotator lookup table that right now shows no strong dependence on the elevation and rotator angle in the residuals, but there is a larger scatter than would be expected from the statistical uncertainty in the wavefront measurements alone. So that's an area that's under active investigation. Another area that we're working on is the filter focus offset lookup table. We are seeing mostly stable performance after filter changes in the UGRIZ filters in January for the pre-LSST observations. There's still some questions about the Y filter. All this is indications that we think that we can further improve the performance relative to where we are today. There's also several additional improvements that are in development and that are not strongly dependent on the details of the scheduler configuration that we're using. Next slide. Oh, could we advance to the next slide, please? Okay, so this is the high-level summary of how we've been using the time during the early operations period. So we came back from an engineering maintenance period that was scheduled for the early part of October, returned to dedicated on-sky engineering. Throughout November and December, we were mainly doing dedicated on-sky engineering tests, primarily optimization of the active optics system, but with some interleaved pre-LSST observations to have a baseline of performance. Starting in January, we began running sustained pre-LSST observations effectively every night for as long as we could. And during the past month, we've been exploring different variants of the baseline LSST survey strategy so that we could have an informed recommendation for any modifications that we would like to propose relative to the baseline that had been recommended by the SCOC. Our plan for February is to continue those sustained pre-LSST observations, and in particular to converge on a candidate configuration that we could recommend on a technical basis for the start of LSST. During that time period, we intend to take routine observations of the LSST deep drilling fields where there's deployed template coverage. And so we would routinely be producing alerts for the community during this period. And then as Phil mentioned, in March, there's a 3-week scheduled maintenance period, and then we'd have to evaluate where we are technically after that point. Next slide, please. Okay, so this is a more detailed view as to how we've been using the time. What you see here on the horizontal axis is basically each column is 1 night. Vertical axis is the time between the twilights. So the black dots are the -18-degree twilight. Gray dot is the -12-degree twilight. Green is when corresponds to each of the visits where we're doing the optical focus and alignment. So you'll see that this is typically happening at the start of the night. Orange is when we're doing dedicated on-sky engineering. This has mainly been active optics optimization. And then the blue is when we're doing the FBS-driven pre-LSST observations. So you can see overall there's this shift that you can see that happens right around the start of the new year 2026, where we began running these pre-LSST observations, basically full nights every night. If you go to the next slide, I have some annotations to point out. So the first of these is that the 2 highlighted regions in red, you can see the first one was in mid-December. This is when we determined that there was sufficient reliability of the Summit electrical power utilities and the dome control systems, including the dome aperture, that we felt comfortable being able to extend the routine open dome nighttime observations all the way to the -12-degree nautical twilight, that we could do this safely on a routine basis. And then as you get into the past week or so, kind of in mid-January, you'll see that we started earlier in terms of the feature-based scheduler. We've now started as early as -13-degree twilight. So we were able to do this by basically determining the sky brightness levels over which we could begin the initial optical alignment, and also reducing the number of iterations, making that whole process more efficient, so that now we're effectively running the pre-LSST observations the full period between -12-degree twilights. Next slide, please. Okay, and then I also wanted to point out some of the gaps that you may have noticed on this diagram when we were not observing. So one of the challenges that we've been facing is that we're in the season, the time of year in Chile at Cerro Pachón, where there's higher humidity than typical. And so what happened is that in sort of mid to late December and through January, we've had this period of very high humidity. And I'll talk about some of the mitigations that we're using and that we expect this to be much less of an impact going forward. In the past week, we had an interruption of the dynolene coolant flow to the top end assembly of the telescope, and this resulted in the telescope the camera we needed to power down the sensors. And there was a recovery period where we got the dynolene stable again, and then we're able to cool down, establish the vacuum, an LSST camera, and we were able to resume testing on the 27th of January. Next slide. Okay, so one of the ways that we're increasing the system availability is that we have added insulation around the utility lines that carry the dynolene coolant to the telescope top-end assembly. This was work that was done over a period of weeks in January, and this has substantially reduced the accumulation of water condensation during these high humidity conditions, and that's allowed us to begin operating over an expanded range of dew point temperatures. So we expect to be much more robust to these effects going forward. And I've included some photos where you can see those lines with the black insulation material around them. Next slide, please. And then this is a summary of basically, you can think about it as the fraction of time each night that we spend doing active observing. And we're using a kind of a simple proxy here in order to just make it a very simple story to tell, where we're basically saying whenever we are continuously observing and we have visit gaps of less than 5 minutes, so basically shorter than the period of the longest slews and filter changes that we would expect, we consider ourselves to be in an active observing mode, that we're not interrupted by faults or transitions between tests. So that we have different color points on this diagram that represent different ways of measuring this, depending on which astronomical twilight you're considering. The green is specifically within our FBS-driven pre-LSST observations. But the point that I want to call attention to is that during this period in January, when we've basically been running the pre-LSST observations for full nights, we're achieving an uptime and active time that's typically between 80 and 90% on most nights. And we expect this to be representative of the performance that could be achieved if we were to start running the LSST at this point. There's going to be continued work on making this even more efficient, but it's significant progress. Next slide, please. Another way that we're increasing the observing efficiency is just by looking at the rate of acquiring visits. So the news here is that during the pre-LSST observations, we've been able to reduce the median time between visits from around 10 seconds to about 8 seconds, which, it only sounds like 2 seconds, but when you consider that the cycle between visits is about 40 seconds, it's about a 5% gain in the overall efficiency. This was done by optimizing the software timing controls and the interactions between the telescope subsystems. And you can see on the plot here, the night that we made this transition, that green bar that represents the settle time after the slew has been diminished. We anticipate that further optimization of these software controls can remove the 2-second wait time that's shown in blue on this plot before the TMA slew. That's the telescope slew, and that's work that can be accomplished on the month time scale. And then for the orange, which is the actual time that's spent in the telescope motion, we're currently running at 20% of the maximum commanded TMA motion settings. If we were to increase this, we could reduce it a little bit, but the effect would be relatively marginal in terms of the overall survey speed at the percent level. And the reason for this is that our survey strategy in the baseline is mostly 3.5-degree slews to adjacent LSST cam field of view pointings. And during those short slews, you're not actually limited by the maximum angular velocity. It's primarily the settle time. And so we're approaching the point of basically asymptoting towards our design technical performance in this category. Next slide. Okay, this is a slide with a lot of information because I thought that this slide would be visible to the broad science community, and it's relevant for a lot of the discussion on the active optics. I don't necessarily want to go through all the details of this slide, but please do feel free to ask questions. I thought it would be helpful to include this technical primer. The very concise summary is that we have been prioritizing on-sky engineering activities that would particularly help to inform optimization in the trade space between achieving a reliable image quality when we're doing this wide and fast survey and the survey strategy. The way that the LSST survey strategy works with the regular filter changes, the large slews to cover the sky quickly, it's very demanding for the active optics system, in particular the open loop control system. And to the extent that the open loop control system can be further refined, it means that the closed loop control system has to work harder to keep up and to make the refinements as we're going through the survey. So I'll talk about a little bit of that interplay in the next slides and show some examples of what we're working on specifically. Next slide, please. So this is the summary of the delivered image quality. This particular slide is looking at all of the early operations period, all of the pre-LSST observations to date. It's important to emphasize that because we've been doing these experiments with different variants of the baseline LSST survey strategy, this basically includes information from a variety of different configurations. There were some periods where we had a constraint on the elevation above 40 degrees, periods where we had constraints on the rotator angle within the night. There are some nights where we ran with only a single filter and no intranight filter changes. And then we've had some nights where we've had inserted AOS closed loop iterations. And then finally, some nights that were just the baseline LSST. But even considering all those different variants, you can see that the typical delivered image quality, that the median in many of the bands is below an arc second, with typically better performance in the redder bands as expected, and then a median of around 1.1 arc seconds in the bluest bands, G and U. So I'd say that this is on target for being able to deliver a sub-arc second survey, and we know that further improvements are possible. Next slide. This is the same type of plots, but specifically showing the period in January where we've been running the sustained pre-LSST observations, and in particular using effectively the baseline LSST configuration, with the exception of having inserted these AOS closed loop iterations after the filter changes that were designed to help us to refocus the optics more quickly after one of the filter changes. This was a near-term mitigation, but it also allowed us to just investigate the performance and get a sense as to whether this mitigation would be needed. I see a hand from Meg.
I just wanted to ask about the G band, because the G band seems a lot worse. Is there a particular reason why that didn't seem to respond as well?
Most of this period has been in bright time, and we actually haven't had the G-band filter in as much. So this could be a statistical variation. I mean, we do expect that the delivered PSF in the bluer bands would be larger than the redder bands. I don't know if we have a firm statement here, but we haven't had as many observations in G during this particular period.
Okay, so worry less about it because you'll know more in February. So like,
yeah, that's partly why we want to continue these observations in February, is to get that assessment of the reliability. Next slide, please. Okay, this is the detailed trending night by night of the distribution of delivered image quality. For the very high level summary, if you look at the black points with air bars, this is showing the 10th, the 50th, and the 90th percentile of the delivered median per visit PSF full with half max. So you can see that there's variations from night to night. There are some nights that are kind of at the level of 0.8, 0.9 arc seconds, and this goes up to 0.1, 0.2 arc seconds with some outliers where we've had poor seeing. The gray bars are the estimated atmosphere contribution that comes from measurements on the wavefront sensors. And then the blue, the red, and the purple are three different ways of estimating the instrumental contribution, looking at the variation across the field of view, the estimated optics and camera diffusion, and then the delivered image quality, and then subtracting off the estimated atmosphere and quadrature. So we think that each of these different metrics is getting at the system contribution in different ways. None of them are giving us a complete picture, but the ensemble is a helpful diagnostic for understanding where we stand. I think the other thing to point out here is that because we've been using different configurations of the survey, not all of these nights are directly comparable because of the different constraints. But if you look at this period in January, where we have been running effectively the unconstrained baseline LSST, the system contribution to the delivered image quality is typically between 0.45 and 0.5 on many of the nights. Next slide, please. I just wanted to show examples of what some of the recent nights look like. So the next 3 slides are just going to show the trending within the night. And an indication that things are working well, that the optics are stable, is if you look at the green plus points, that is the estimation from the wavefront sensors of the optics contribution to the delivered image quality. And when that green set of points is basically flat and stable throughout the night, this makes us happy. This is an indication that, as we're making these filter changes, as we're moving in rotator angle and elevation angle, that we are maintaining a stable optics contribution. Another way to look at this is that if you look at the blue points, this is showing the distribution of the delivered image quality in terms of the variation across the field of view. And then the black is the estimated contribution from the atmosphere. And so what we see on many of the recent nights is that basically the delivered image quality is varying up and down with a high correlation to the atmospheric contribution, which is an indication that we're primarily being limited by the atmosphere rather than the contribution of the Rubin system itself, which I think is encouraging. So if you go to the next slide, this is just going to show a different night. I think I picked three random nights, the 15th, the 16th, and the 17th. So you can kind of see similar trends. And then if you advance one more slide. So again, the feature to call out here is that on many of these recent nights where we're seeing a stable optics contribution, over multiple hours of contiguous observations. Next slide, please. One of the specific analyses that we've been looking at to evaluate the open loop performance is that when we have these filter changes, we have added these inserted AOS closed loop iterations. And this has been a helpful diagnostic because it allows us to directly see what is happening with the optics control as we're going through these maneuvers that would be characteristic of the LSST survey. And so when we're looking at the filter changes in the past couple weeks between the U, G, R, I, and Z, we observe flat trends for the estimated optics contribution and the delivered image quality for the subsequent visits. So the way to look at this is that on the plots, the horizontal axis is the visits after the filter change, and this is 0 indexed. We would expect that the first iteration, basically the first set of corrections for the AOS, would be applied at visit 2, and the second iteration would be applied at visit 4. At visit 0, there's actually no active optics correction that's been applied from the closed loop, and so you're just relying on the open loop. And then as you go to further visits, that would be the continuation into the main part of the survey. The black is the median of the metric that we're looking at for the optical performance. And so the left plot is showing the estimated optics contribution, and then the right plot is showing the per visit median PSF. In both of these metrics, you'll see that median trend line is basically flat. And this is what we would want to see in the sense that it's an indicator that the open loop control system is not it's not limiting us in terms of the performance when we're making one of these changes. We do still think that there's ways that the open loop performance could be improved. There's active investigations of the Y filter that was just reinstalled earlier this week. So I don't want to say that we are done. We expect that there will be improvements, but this is looking stable from the standpoint of evaluating when to start the LSST. Next slide, please. Okay, this is the last slide that I was planning to show. It shows just an example of some of the current image quality development efforts that are happening in parallel. As I mentioned, we're continuing to do the refinement of the filter focus offset lookup tables. We're continuing optimization of the closed loop AOS control system, and this includes even tuning the gain on the individual degrees of freedom that we're controlling. We're working towards a faster closed loop optical corrections for the survey mode observations. And the figure that's shown here is showing the breakdown of the time between when the shutter closes and when we're able to calculate the corrections to apply to subsequent visits. The orange histogram is showing that for many of the visits, we're able to compute those corrections within 40 seconds. If we can get that correction calculated consistently below 35 seconds, we would be able to apply the correction with the lag of only 2 visits. So we wouldn't be able to immediately correct the optics. We would, on the very next visit, but on the second visit later, we would be able to apply the correction. And this would just make the closed loop be able to keep up with the observations even better than we are now. And then there's also some planned updates for the pointing model that are in the works, as well as several other activities that are in the queue. Let me stop there and just pause if there's any questions, or we can move on to Eric's slides. Meg?
I've heard the good news. I haven't heard why you're not down at performance. So can you explain why? Because I'm getting these questions. What am I supposed to tell people about why we're not ready? Because both reporters are starting to ask that question, and the collaboration is starting to ask of like, if all this work has gone in and we hear these positive things, why is the system not yet where it is? What's missing? It sounds like there's something that's correlating with temperature. But what I haven't yet heard an official line that I'm supposed to tell people, because this is all positive and great and see that you're working towards it. But I think people are trying to understand that the end of March is a year of on-sky commissioning. What's not getting us into the spec, right, or the full box, right, of the LSST? It sounds like there's a time varying or something component that's something with temperature that isn't yet in the model, or which is, I know there's a million things that could be, but I'm trying to understand what I can tell people, what, a simple to understand thing of what is the investigations that are happening, right? Or what's the thing that is the hard thing that's still to do. Because I think we haven't heard, I feel like there's a lot of stuff that we hear as chairs and a lot of things that are sort of said sort of in a positive spin. There's a lot of lack of information to everybody else. And so what can I tell people from this meeting about why we're not there and like what we're going to learn in February? So it sounds like we're going to learn to live with the system in February, but it doesn't mean you're going to necessarily solve the problem in February. So can you explain what is missing in the active optics analysis or interpretation or model that is causing us to be not at spec in terms of this delivered scene?
I would.
Keith.
Do you want me to give a first shot, Phil?
Yeah, go ahead, and then I'll add a little bit at the end.
Yeah, I mean, so I would say that, I mean, just on technical grounds, if there was a really straightforward solution, that's what we would be pursuing. We are at the stage where there are real technical challenges and active investigations. And if we knew that there was a straightforward solution, like that would be the path that we were directly pursuing. I would say that there are multiple lines of evidence from the different investigations that we've been doing that in terms of the repeatability of the optical state within a night on an hour time scale and from night to night, that there's basically some larger variations than would be expected from basically the statistical uncertainty on the measurement of the wavefront alone. And so it appears that there are one or more additional variables in the system that perturb the optics in measurable ways. And this makes optimizing the open loop control system, which is intended to basically correct for the predictable effects, it makes that more challenging. And then we have to rely more on the closed loop system. And so that's why we're working both on trying to basically look at all the different types of telemetry that we have about the system to try to identify what these additional degrees of freedom could be, and doing targeted engineering tests to try to identify that. I will say that it's challenging and it's baffling, and many of us on the team are looking for answers, and we're looking in a lot of different places, and we don't yet have a first principles physical model at this time. That is what we're working towards. In the meantime, we've been exploring different variants of the LSST survey strategy, recognizing that being able to do intranight filter changes and being able to survey large parts of the sky and be able to do the deep drilling fields are all critical parts of the survey strategy that we're not willing to to stand down from in terms of the LSST science goals. And then we're also working on the closed loop performance. For example, this plot here, showing that we're working on being able to provide the closed loop corrections more quickly, should also be able to help. So I don't know if that totally answers your question, but we are doing the best that we absolutely can in bringing all of the technical expertise that we have to bear on the problem, that we're not holding anything back.
I guess as I worked at an observatory, I understand how complex this is, but I don't think we hear from the observatory. We hear publicly, I would say we hear you're doing some things, we're optimizing, and then we're not hearing much else. And so I think telling people that the system is where it is, and that this is a very challenging problem because something's changing with temperature, and that is, it's a multivariate problem. So we're moving towards a system where we're trying to figure out how to live with it. But the problem is it's the chairs telling people, right, or disseminating it in ways that aren't coming from the observatory. And so, what is the one-line answer I can give them that's accurate? I don't necessarily know, because we don't necessarily see it in slides or a statement or a presentation from the observatory on this. So this is helpful because then I can at least communicate that. My worry is that the community's hearing it from the chairs and not necessarily from it's great to see the summaries on community, and I can parse that, but not everyone can fully parse it. So we don't really fully understand what's going to happen in March. Right. Mm-hmm. And we need to start preparing to understand that. And so I guess that's the one plea I would have, is that getting more information of where it sounds like we're heading towards. Everyone's done as much as they can do right now. You're going to need more data to figure it out, which means that LSST is going to start soon, but you're going to put as much mitigations to make it as good image quality as possible for us to get as good data while you're figuring out this really complex and really challenging problem. But I think we need to hear some things or ways to say it so that we make you all look amazing because you all put this hard work in, but I don't have the language necessarily to say that to my science collaboration, or if a reporter asks me, and having some help would be really useful on that. And so I was kind of surprised not to see those bits in there. So I guess maybe that's something for you, Phil. It would be really helpful to get something that's the right soundbite for that.
Yeah. No, I hear you, Meg. I mean, the way I think of this is it's, as Keith was saying, we're tuning up a complex system. It has been steady progress through this period of early operations optimization, but it's been one of addressing one thing after another and keeping on testing. We will carry on doing that during year one. It's important to recognize that at some point we'll declare the survey started, but we won't stop working on things like the lookup table and the thermal control and so on. And we'll keep on figuring out. We'll need to decide what data we need to take as well as the LSST observations in order to do that. But we'll be simulating that during February, and then we'll keep going when the survey starts. But I understand, I think, what you're asking for, and we'll look at giving you the words you need in sort of summary form whenever we put out a post to community or communication like that. But thank you. Okay, I suggest we switch gears and move over to look at the other part of the Rubin system, data management system, and how that's doing. So, Eric, are you there?
I'm here.
All right. You let me know when you want me to advance.
All right, next slide. All right, so as I think folks have heard or intuited, we are getting geared up to start public Rubin Alert production next week on the night of February 4th is our target. Obviously, weather and other things willing. We have been working over the last several months on integration tasks with the community alert brokers, and so we're getting generally readiness signs from them. They also have been working extremely hard behind the scenes. They have been able to confirm that they can identify transients from the data stream, which suggests that the science is achievable. And so our goal in beginning public alert production is to enable early community science to start this process and get folks engaged. And I think that I will be the first to acknowledge that there are still I's to be dotted and T's to be crossed. But my experience in many projects has been that get more eyes on data and we improve much more quickly. And I would say even already with our work with the broker teams, they've identified issues that we've fixed and improved. So I think there's science to be done, and we can enable that very soon. Next slide. So again, we rely on our community alert broker partners to receive and distribute the alert data. I've listed the 7 full stream brokers here, and there are also 2 downstream brokers as well, snaps and POI variables. And again, they have been working very hard over the last months to provision their services based in part on the ZTF experience, but also they've been preparing for Rubin scale, Rubin data formats, and so on. It's worth emphasizing that at first alerts, the community brokers will be basically the sole interface to the alert data. So you will need to go to a broker to get alerts. There will be, in ways I'll describe in a moment, other interfaces to the alert data in the RSP and so on for data rights holders, but those are coming later in the year. So again, the message is that we're getting data to you absolutely as quickly as we can to try to enable that early science. Next slide. These are just a couple of plots from some of our dashboards, just showing kind of some of the performance we've seen over the last month or so. On the left is kind of an alert count, a cumulative alert count from the Kafka system. We're getting, sort of tens of thousands of alerts nightly. That's a function of fairly limited template coverage in the deep drilling fields, and also, a mix of both wide area surveying, as Keith showed, but also, some degree of engineering activities as well. In terms of alert timing, you see on the right, each sort of colored set is one visit, and so you have 189 CCDs that are all independently processed, and so you get anywhere from 2 to 3 minutes sort of processing time for the alert stream at the moment. Next slide, please. I pulled literally this is the first image I grabbed. It happens to be a wideband difference from Cosmos, just to give you a kind of a visceral sense of how the image diffraction looks. You can see some residuals around bright stars. Those are characteristic, but the thing I'll draw your attention to is that we're only alerting on the red circled objects, which I think look much more nicely PSF-like. We did a fair bit of work in the fall on sort of masking and excluding artifacts from diffraction spikes, and I think that you're seeing that pay off here. So, the stream is not perfectly pure, but we have removed quite a large number of false positives along the way, and so hopefully that will bear fruit scientifically. Next slide. As Phil advertised in February, our plan is to focus on the deep drilling fields for alerts, because that's where we have the highest quality and actually the only templates at the moment. So you can see we have Cosmos, ECDFS, Elias, and EDFS templates deployed at the moment in most of the bands. All but Cosmos are studying relatively quickly, but we should be able to get some observations through February. The fact that it's constrained in area means that, again, the alert volume will be manageable. That makes it easier for brokers and doesn't overwhelm everybody. And also means it's a little easier to coexist with any ongoing optimization activities. We also have some data for XMM and for the M49 Virgo first look sort of fields that we're probably going to deploy as well relatively quickly once we get the vetting completed. Next slide. Looking ahead, because this March downtime provides kind of a natural division where we can, again, just focus on the DDFs in February, deal with other sort of, deal with user questions and so on. And then after that downtime, we'll be prepared to ramp up to increased template area. There are some areas from the science validation surveys you can see on the right where we do have some templates, and we can perhaps piggyback a little bit on some of the DP2 processing to get some wider area coverage. Those are mostly sort of summarish fields, so we're not really missing anything at the moment. The other thing we're going to work on is ramping up the incremental template generation from the wide area, wide, fast, deep type observations as more of those are taken. At the moment, there really aren't substantially large areas that have enough images for templates at the moment. So we are refining our selections and our processing pipelines for that to sort of make sure we can scale that up. Meg, I see your hand.
More a question for you about what goes into a template right now. How many
Yeah.
observations are in a template? Or are you making any cuts? So you're just taking your first 3 images?
Yeah, so
I guess you probably don't have it like optimized, but any kind of guesstimate of what you're currently doing would be useful.
yeah, the DDFs are special because we have lots of images, and so we can make really nice templates there. So we can include as many as 20 images. We typically have cut below full width half max of like 1.4 arc seconds. Although if you look at Keith's distribution, like we could maybe tighten that up a little bit because the seeing distribution has improved over time. That's one of the, I think, challenges for us is trying to the image differencing performance improves with better seeing templates. And so we're sort of trying to balance the evolving camera and survey performance with, getting templates getting started as soon as we can. So we are trying to figure out like what exactly is sort of the bare minimum for the wide, fast, deep, so that we can start deploying as much area as possible, as soon as possible. All right, next slide then. We are putting together some documentation in a format that will be quite familiar to you. This is in partnership with Melissa and the CST. It'll live at prompt-products.lsst.io. It's not deployed yet, so don't look just yet, but we'll have pointers to observation status, dashboards. Meg, there have been many folks, including Meg, have asked about, can I see where the templates are right now? And yes, that's something we're working on. So this will be sort of what I think of as the one-stop shop for questions about alerts and so on going forward. Next slide. This is taken from RTN 11, and this is just to remind you. So we're on track for the first alerts in the January to February timeframe we advertised. Initially, we're not able to make available the images themselves from prompt processing, but the images and their sort of direct image catalogs we expect in sort of the April to June timeframe is our current target. and then the access to the PPDB catalog, which is sort of a queryable version of the alert contents. There's no new information. It's just sort of organized in a database rather than in alert packets. It's not before June of 2026. And there's some, we're going to make sure that doesn't interfere with the DP2 schedule. So that's kind of why it's a little bit, it's just a not before date at the moment. Next slide. Again, we're trying to get alerts to you as rapidly as possible, and so I was quite willing to throw things to after first alerts. So there are features we know we want or need that are not going to be present on day one, but we think they are science usable. Most notably, we're continuing to refine the real bogus model. We just did a big Zooniverse campaign. We're digesting those labels and tuning up the model performance now. If you're looking for young supernovae, force photometry is nice, but it's a little delayed. So we promised many years ago to add upper limits in the alert packets, and we have a vision for how to do that. That needs to get implemented and delivered. There are a few fields that are not populated yet that we're working on. If you're interested in NEAs in particular, you really care about the precise shutter timing. That's been a little slow being delivered, but we are on that's in progress. And finally, we expect to get lots of feedback from users as soon as we do this. And so we think we'll be spending at least a good chunk of February responding to community identified issues and questions. And so continuing to either fix problems or expand the documentation in ways where it's lacking. So my next slide, I think, is my last, which is just to remind everyone that we welcome your comments and questions at community.lsst.io, and that'll be our primary means of getting feedback once the alerts are public. I think that's all for me.
Great, thanks, Eric. There's a question from Meg in the chat about whether there's anything we can say about the date range for the PPDB. We've said not before June, but is there a late date we can give?
I think end of 2026 is reasonable. That's the target we have in mind for a no later than, or sorry, no later than, but we're making good progress there, and we'll see.
Yeah, and I'll take an action to when we next update RTN 11, try and get back to our practice of giving date ranges, as you say.
Let me expand just slightly here. The reason it doesn't have a date range in RTN 11 is that we would like to be able to deliver some early functionality ahead of DP2 if we can. That's a little bit of a challenge, but it's possible. But whatever is not delivered by DP2 takes precedence. And so we didn't think that it was going to be easy to digest a dual bar structure sort of in that chart. So there's kind of an early window and a late window, but the late window is sort of October, December of 26. So.
Great, thanks, Eric. And I just wanted to add a little something to the question about how many visits per template in order to make a good template, still under investigation. I think it is worth reminding everybody that in year one, we've always known since adopting the plan to make incremental templates that the light curves would be short because it does take time to build up the visits to make a template and then deploy it. And so just wanted to make sure that people have in mind that during year one, light curves will be short, and then we'll let you know as soon as we can how it's looking with regard to template generation and give some predictions for how short they might be.
Yes, and I'll expand on that. Some conversations I've been having with Lynn Jones that, like, in some of the bluest bands, like U band in particular, there are only perhaps 6 visits total in the whole year in the baseline schedule, and so it's really, that gets really tough to sort of make that achievable with bad seeing or slightly slower survey speed. Then you're really kind of up against a wall in terms of what you can get done.
Yeah. All right, thanks, Eric. We're down to our last few minutes, Tesla, but if you can just give me a little bit of airtime, just to summarize. So we're planning for first alerts the night of Wednesday, February the 4th, barring any major unexpected issue. And so things to think about this. I mean, this is a great outreach opportunity. I would say watch out for press releases from NoirLab and Slack amplified elsewhere. There'll be significant activity on Rubin social media, great for sharing. And then, yeah, keep an eye on the website, which is where we'll put up new graphics, more Rubin slides and so on. And then the message for the collaborations is we're looking at several weeks of science analysis with this initial alert stream. So testing in the deep drilling fields is the way to think of it. Low volume stream in well-studied sky regions, a good way to get started with Rubin alerts via the brokers. I got a slide here, just some information on what we're going to be doing in the maintenance period. I think folks can read this as they're interested, but we'll keep the weekly updates going so you know how things are proceeding at the summit. And then, yeah, we just had some discussion about survey start, not before the last days of March at the earliest, and just a summary of what we just said. We just need some more time on Sky in February to confirm reliability of the system. And then we may know by the start of the March maintenance period how soon after that period the LSST could start. And just stay tuned. We'll try and keep up a good flow of information about survey start. And then just one last note is that during February, we'll be doing some work to simulate the year one survey performance with the scheduler configured in the way that we know that it will need to be. And so we'll aim to make those cadence simulations available for the science community to use in their planning. Okay, and so yeah, this to be revised. One last note: we are on track with DP2. It's the production started last week, is going well, and we aim to have that released in July. With the date range here is July to September, but we'll try hard to make it in time for the community workshop. And like I say, it's begun and it's going well. Okay, so I think that's all we have for you, Tessa.
Thank you so much. We really appreciate the updates and the time. We are 1 minute over the hour. I don't know, Phil, Eric, and Keith, if you need to take off right away, or I mean, we can continue the recording for now if folks want to have a chance to ask questions.
I'm happy to stay a few minutes.
Is that okay? Okay, so we can take some questions, and then if we want, we can even, like, if folks would like, we can pause the recording and take some off the record questions too. But why don't we start with on the record questions first?
I'm just looking back through the chat in case there was anything we missed there.
I think we got most of the stuff in that chat. Matt?
Hello, thanks everyone. Thanks for the updates. It's really great to have this level of detail. I don't know if this can be answered on the record or whether we need to go off the record, but I'm curious. There's lots of data that's been taken in January and will be taken in February. And obviously that's not going to DP2. I'm just wondering, is that data ever going to be publicly released? Is there any plans to include that as part of DR1, or is that still not known?
I'd say it's still under discussion. Eric can maybe add more, but the question of when to declare survey start and what to include in DR1 are separate. Okay. And so likewise, the question of what to include in DR1 and what to include in the COADs of DR1 is also a separate question. So we'll look at all of that. I would say there's a strong feeling in the team that having taken good data in this pre-LSST period, it ought to see the light of day somehow. And so we'll be working on it with that in mind.
Thanks.
Are there additional questions for now? Meg?
Just a quick one, or maybe a comment. So I'm very worried is that it sounds like, or I see from Joko's comment, we're probably starting early April at LSST. There's very little expectation of what we're going to get when April happens, right? When, how long roughly templates will be made? Is it going to take a month to make templates of wide sky? Helping to explain to people what we should expect in April and whether I should be like, should people should be moving their schedule in April to find solar system objects, or should that be May, is really needed because people are waiting for data and trying to figure out what they should be doing in their science lives or shift things around in their rest of their lives to be able to work in LSST data. And some think it's going to instantaneously come out. And I'm worried I don't hear that you all know yet those numbers. And if we really are starting in April, we kind of need to know them, but people can feel like, okay, I was ready instead of, well, the observatory just told us that, April 15th, they've already started and, oh, we have templates for this and data's coming. And so I just would like to just advocate for that of the sooner you can communicate us to something about realistically of when, how things will look would be
Yeah.
helpful because I think I know the picture, but a lot of people don't because a lot of people don't fully understand what's going on because they've been half paying attention. And so that would be something of like really helping it because it's more and more of that's going to be coming up as of next week as they go, wait, alerts? Well, what does that mean? Right. And so I think that would just be really helpful is materials and things that can help us explain like, yes, LSST started, but there are no templates. So you're not going to get any alerts really in those areas until mid-May because it's going to take them a month or a month and a half to make it and vet them. So just be really helpful if there's the materials for us that we're not as chairs having to do this information without actually having the official words from you of how long things are taking.
Yeah. No, I fully agree, Meg. It's a great suggestion. I mean, it's how to think about year one, right? What to expect and when, and just I will take that as an action for us to get more information out there to help folks with their planning. I think it's important. Thank you. Colin.
Hey Phil, question. I guess this is mostly for Eric, but I know there was a lot of discussion about self-expanding alert cutout sizes. Is that a thing that is going to happen in this initial batch, or will the growing cutouts be some other time? Comments, AGN, whatever.
We are not doing the cutouts are the size they are. They're fixed size. I mean, sorry. Let me say that. Sorry. Let me ask you. What do you mean by expanding cutouts? There are a few.
If there's a transient that's bigger than the fixed cutout size,
That's been implemented forever. That's already present.
cool. All right. Thank you.
Yep. Sorry, I thought you were referring to a larger than standard cutout for everything, which was a different discussion.
Yeah, no, I just was wanting to ask on the record that bigger cutouts are a thing. Thank you.
Great. I think I'm going to stop the recording now. Thank you again for your time. This is really valuable updates, and thank you for all of the hard work getting us ready for alerts and survey start.